So looking at number 15 on worksheet 4, when is the velocity, when is it moving to the right? Well, when velocity is positive. So let's find velocity. First find where it's 0, and then we'll do the number line thing to figure out where it's positive and negative. This is a velocity number line, so I'm going to check some velocities. I should be able to check just one of them because there's nothing weird about this. There's no double roots. I could use the alternating rule. If I plug in 1, I get negative times negative is positive. If I plug in 3, I get negative times positive is negative. If I plug in 5, everything's positive. So I just confirmed the alternating rule rather than use the alternating rule. Okay, so the question was, when is it moving to the right? When velocity is positive. So I look at my number line. That happens from 0 to 2 and from 4 to infinity. There isn't a stop to this. Speeding up would be where A and V have the same sign. So there's my justify. So I need that the overlapping number line thing. So I need an acceleration number line. Acceleration is derivative of velocity. So that would be 6t minus 18. So it's 0 and t equals 3. So let's check a little less than 3 and a little more than 3. Less than 3, we would end up with negative acceleration. More than 3, we'd end up with positive acceleration. So I'm trying to look and see where they have the same sign. They're both negative right there from 2 to 3. And they're both positive from 4 on. So from 2 to 3 and from 4 to infinity. They have the same sign. So 2 to 3, we're speeding up going backwards. 4 to infinity, we're speeding up going forwards. What is the speed of the particle? So that means the absolute value of the velocity of the particle at time 3. So you know what? I don't have a calculator. I don't want to mess this up. So how about just absolute value of plug in 3? I really have no idea what that number is, but that's okay. It's calculator ready. What is that answer? I don't know. Figure it out if you want to, but I'm not really worried about it. The main thing there is the speed, meaning the absolute value. That's what it's trying to trick you on. What is the total distance traveled? Okay, so probably a motion diagram, or at the very least have to think about when I'm changing directions between 0 and 3. So from 0 to 2, I have a positive velocity. From 2 to 3, I have a negative velocity. It changes at 4, but I don't care about 4. I'm just 0 to 3. So time, velocity, distance. So either a table or a motion diagram, something to keep things straight. From 0 to 2, we're moving forward. From 2 to 3, we're moving backwards. So let's find S of all those places. S of 0 is negative 1. That's an easy one. S of 2, 2 cubed minus 9 times 4 plus 24 times 2 minus 1. And I could just leave that and write my distance as S of 2 minus S of 0 in absolute value bars. But I think it's easy enough to keep up with that it's worth doing the math so that I can get a number and see if it makes sense. Let's see. 48 minus 36 is 12. Plus 8 is 20. Minus 1 is 19. So if S of 0 is negative 1 and S of 2 is 19, how far did we go between time 0 and time 2? What distance did we travel? went from -1 to 19.
Sounds like 20 in there.
Yeah, it sounds like 20. And it's distant, so I don't really even care if it's positive or negative. It is positive, but it doesn't matter. And then I need S of 3. 3 cubed is 27, minus 9 times 9, plus 24 times 3, minus 1. Ugh. So do I really want to do this? There's a way to safe stop this. You'd have to include absolute values, or know which one's positive, because you want to do S of 3 minus S of 2, but make sure it's positive. So you could safe stop it, or you could just kind of figure it out here. 81 is the negative version. Oh, minus another one is, so that's negative 82. 24 times 3 is 72. Plus 27 is 99. So I've got a positive 99 and a negative 82. That makes 17. So if I go from 19 to 17, what distance did I travel?
2.
Positive or negative?
Negative. Right. Or is that absolute value?
Distance is always positive. So yes, we went backwards, but that doesn't matter for distance. So the distance was 2. So total distance, 22. Again, the total distance question is always a pain because you've got to stop and figure out, well, where did I turn around? So how far did I go to the right? How far did I go to the left? And it's just a pain to mess with.